In section 1.6, we're going to talk about measures of spread. So we've talked about spread before, but not specifically. Like the range of data would be how spread out it is. The IQR would give me the spread of the data. There is another measurement in objective A. We're going to compute and interpret what's called the sample variance and standard deviation. It's a very common calculation used to determine and quantify spread of data. So again, we talked about here the measures of spread we previously talked about were range and IQR. They're numbers that kind of give us a visual representation of the data. What they want us to do here is to look at this particular data. We have the heights in inches of these two different women's basketball teams. We have the Dolphins and the Sweet Peppers. And these are called dot plots, so we see that. They want us to compute the mean, median, mode, the range, and the IQR. We're not going to do this right here. So what I would do is go to my calculator, back what we did in section 1, and I would do stat edit. I would enter all these pieces of data. So I would do a 70, 71, 71, do a 73, 74, 75, and enter all those datas. When you do a one variable statistic on it, remember the mean on the calculator is the X bar. Okay, X bar for the Dolphins is going to be 75. If you scroll down on your calculator, the median will be 74.5. The calculator does not give the mode, but the mode means which is most frequent. For this one, we have a tie between 71 and 79. So we actually do call that bimodal, by the way, and that's fine to have two. There could be three. The range is going to be 80 minus 70 or 10. The IQR would be Q3 minus Q1. When you look at Q3 minus on the Q1 on the calculator and subtract them, the IQR will be 8. If you do the same thing for the Sweet Peppers and you put all the data in, be careful. You're going to type 75 in 6 times, so do that. When you do the X bar on that, you're going to get 75 for the mean. The median is 75. The mode on this one is 75. The range here is 10. And the IQR ends up becoming 0 because Q3 and Q1 are the same number, and that's fine. So as of now, what we have to look at spread is IQR and range. And if you just looked at the numerical values and you said who's more spread out, well, they both have the same range, so I can't tell. But on the IQR, the Dolphins have a higher IQR than the Sweet Peppers, so you would probably say the Dolphins are more spread out. Well, there's a third calculation, and it's the standard deviation. Let me show you how it works, and I'll show you that the calculator does give us this information too. So first, let's talk what deviation is. To deviate is going to be the difference of each data value from the mean. So back to the Sweet Peppers, the mean was 75. So if you look at the tallest girl who was 80, how much did she deviate from the mean? She deviated 5 inches on the positive side. Okay. We have what's called the population variance, and what that's going to be is the sum of all the squared deviations. So I have to take every player in the team, see how much they deviate from the mean. I have to square them, and then I add them up, and that's called variance. And if you look at it, variance right here, for the population variance, is this Greek letter called sigma, and it's sigma squared. And what they're doing is this right here. You don't necessarily have to understand this, but maybe you will. Take each piece of data, subtract the mean, square them, and add them up. They're then going to take all of that and divide by how many players there were on the team. And that's called the variance. Then the population's standard deviation, though, is going to be this right here. It's a very similar calculation. The only difference is they come in and they take the square root of the variance. So this here is the standard deviation of the population, and it's sigma. This value actually does show up on your calculator when you do a one variable statistic, so we do not have to compute it by hand. But I want to show you, and let's talk through how the calculator actually does the computation. So they're going to compute it by hand, and please try to follow this one. This here is going to be for the Dolphins team is what they're doing. So what they've done is they've taken all the ladies in the Dolphins team, and they're going to find the deviation. because remember, we want to find the sum of the squared deviations. So we start by finding the deviations. So I take the first player minus the mean of 75. This gal is 5 inches shorter than the average. And you do that for every single player. And those are the deviations. We're then going to come in and square those deviations. So negative 5 squared is 25, negative 4 squared is 16, and so forth. Then they're going to sum those deviations. If you sum those up, it's going to total 128. Now, the definition of variance said they're going to take that total and they're going to divide by how many players there were, and there were 10. So they're going to take 128 divided by 10, and they're going to say this sigma squared, or the population variance, is 12.8 inches squared. Because you have to be careful on the label, this first deviation here is negative 5 inches. When they come in and square it, it's 25 inches squared. So this label down here is inches squared. Now, if they could, they would stop with this calculation and use what's called variance, but inches squared in terms of women's height makes no sense. So they have to come in to make this logical. They take the square root. Well, when you take the square root of this sigma squared, it becomes sigma, or standard deviation. And the square root of 12.8 is 3.58 inches. So what this is a calculation of spread. It's called standard deviation. It is, on average, how much someone on this team deviates from the mean. Now, I will tell you, so I'm going to put here that this is for the Dolphins. I went back and did the sweet peppers, and if we do the same thing for the sweet peppers, their standard deviation calculation ends up coming in at a 2.28. And if you recall from the data before, remember the IQR for the sweet peppers was 0, so it looked like they didn't have a lot of spread, versus the Dolphins had about an IQR of 8. So if you go to the standard deviation, the team with the higher number has more spread. If we look at the graph, the Dolphins looked like they had a lot of spread in their data, and they do have more spread because the numbers verify they deviate more from the mean. Now, there's a second standard deviation. It's called the standard deviation, or the variance of the sample. And on your calculator, you're going to have two different outputs. You're either going to have that little sigma symbol like that, or you're going to have a little s with an x. This one here is a standard deviation of the population. This is a standard deviation of the sample. There are two different ones. In statistics, you have to figure out if you're dealing with a sample or a population and figure out which number to read from the calculator. I just want you to notice the difference here. You're not going to have to worry necessarily about the formula, but it's very similar. What this says is you're going to sum. This is how much you deviate, and you're going to square those. The only difference is they divide by n minus 1. And n here is your sample size. So on our girls basketball team, our sample size was 10. So here, instead of dividing by 10, you divide by 10 minus 1, which is 9. And this is called here the sample variance. When you take the square root of variance, you get what's called the sample standard deviation. And this S is what shows up on the calculator. So let's just go, and I'll show you a calculation using the sample standard deviation real quick. Now, I am going to skip this slide on the earthworm example, and let's actually go to the calculator example, and I'll show you how to find the sample standard deviation with the calculator. So here, they want us to use our calculator to find the standard deviation of this following data set. So what you're going to want to do, and we've done this back in section 1, remember, you're going to want to enter this data. So you're going to do stat, and then select edit, and type these into your list. Then you're going to go back to stat, select calculate, and calculate a one variable statistic on list 1. When you do that, we're going to get this data here. Now, the two things that are important to see are right here. An S of x and a sigma sub x. S of x is the sample standard deviation, and this sigma sub x is the population standard deviation. Now, the way that I like to remember it is the population has an O in it, And this little sigma sign kind of looks like an O, versus the sample standard deviation starts with an S. And so I know that goes with the S here. What these are not is you will never ever see variance calculations on the calculator, just standard deviation. So if we know here that they're taking a sample of data and they ask me for standard deviation, I would say the sample standard deviation equals 10.1. If they said, hey, it's a population, I would say that the answer is 9.4. Now, in most cases in statistics, we're taking a sample. So when in doubt, we're going to be using the sample standard deviation or this S of x here. Now, one other thing I want to highlight is what if I asked you, I gave you this calculator output and I said find the variance. Here's what's important. Remember that standard deviation is equal to the square root of variance. Well, let's say we're looking at the sample. If I know the standard deviation of the sample is 10.1, I'm going to put that in here. And if I ask you for the variance of this, don't let this throw you off. It's actually easy to find. All you have to do is get variance by itself. To get rid of a square root, you're going to square both sides. So if I take 10.1 and square it, I know then that the variance is going to equal 102.01. So you have to compute the variance from the standard deviation.